For the derivative of the function f at a number a, which is the same thing as the slope of the tangent line, this blue line, at a point P. And we are going to use the slope of the secant line to obtain the formula for the slope of the tangent line. Just like before, we want this Q to be very close to P. Previously, we gave a name for the coordinate of Q, x coordinate of Q. We called it as x. So we were really focusing on the x coordinate of Q. But now we are going to focus on the distance between the x coordinate of P and x coordinate of Q. And we will call that distance, let's say this distance, we will call it as h. Now, if the x coordinate of Q is x units away from x coordinate of P, we will have a plus h for the x coordinate of Q. So we already had a, we go h more units, so we get a plus h. Then the corresponding y coordinate will be f of a plus h. All right. So here are the points. So we have Q, a plus h, comma, f of a plus h, and we have P, coordinates are a, comma, f of a. So the slope of the secant line between P and Q is y2 minus y1, so that's f of a plus h, minus f of a, divided by x2 minus x1, which is a plus h, minus a. Once I simplify, I get MPQ equals f of a plus h minus f of a divided by, well, we have a minus a here. They will cancel. So we get h. So this is the slope of the secant line formula. And remember, we want this Q to be very close to h, meaning, very close to a. So meaning this h is going to be almost nothing. That is, h will become 0. So here's our formula for the tangent line. So m tangent equals limit. Once again, we want h to be very small so that the distance between P and Q is very small. So h will be 0, going to 0, of f of a plus h minus f of a divided by h. So I can write the derivative formula just like before. So f prime of a equals limit as h approaches to 0 of f of a plus h minus f of a divided by h. That is our second version of the derivative formula.